Hi guys, it's Cindy, and today I'm going to be talking about the wave nature of light, and more specifically Young's double slit. Before going in depth about Young's double slit, I'm going to talk about why he decided to do this experiment, and it was due to these two models. So, there was Newton's model and Hutchins' model, and the reason Thomas Young did this experiment was to prove that light behaves like a wave, just as Hutchins proposed. Newton theorized that light travels in bundles of particles called corpuscles. Now, the benefit of his theory was that he could explain how light has different colors, and this was due to different masses. And he could also explain that reflection was due to momentum. But the downfall of his theory was the fact that he couldn't explain interference, refraction, and especially collision, because no spark or explosion occurred when two light sources interacted. On the other hand, Hutchins theorized that light behaves like a wave. The benefit of his theory was that he can show that light exhibited wave-like properties, such as refraction, reflection, and interference. But he couldn't prove what medium light traveled through. He said that it was an invisible medium called ethers, but that was a downfall to his theory. The main components of Young's double-slit experiment included summary, reasons for success, diagram and its components, path difference, interference, and assumptions. A little summary about Young's double-slit was that he conducted this experiment to prove that light was a wave. Using monochromatic lights, Thomas Young shined the light towards a single sheet, creating a coherent light source. The light was then shined into a double slit, creating two coherent light sources, and the two lights interfered with each other, constructing and destructing, creating light and dark spots. Reasons of success behind this experiment was the use of a monochromatic light, which is a single wavelength, which caused the light not to have any prism effect. The use of a single slit was also really important since it created a coherent light source. The use of double slits spaced extremely close to one another rather than two different light sources was another reason for his success. Diagram and its components. This diagram over here shows Young's double slit experiment. S1 and S2 are slits creating two coherent light sources. D is distance between the slits, which is really small. X is the distance between the slit and the screen. Y is the distance between the center and the bright or dark spots. And finally, that squiggly is an approximation that two parallel lines converge. Path difference. So in order for both rays to meet at one point, one light source, in this case S2, must travel further than S1. Interference. So constructive interference is when the path difference is a multiple of one wavelength, which causes a bright fringe. And destructive is when the path difference is a multiple of half a wavelength, causing a dark fringe. If it's any other multiple of a wavelength, it won't be a bright spot and it won't be an extremely dark spot either. Assumptions. There's an approximation of distance where you approximate that the two parallel lines converge, and there's another approximation of angle where you approximate that sine theta equals to tan theta. In this diagram, you could see that D is your hypotenuse, which is the distance between S1 and S2, and your wavelength is at the bottom. We know that sine is equal to opposite over hypotenuse, so we could say that wavelength over distance is equal to sine theta. We know that n is the order of the bright spot, so we could also say that n lambda equals to d sine theta. In the next diagram, we could use the approximation of small angles to determine that tan theta is equal to sine theta. We could then say that tan theta is equal to y over x. So now we could say that sine theta is equal to y over x. We could plug that back into our original equation and completely eliminate sine theta. So we have that n lambda is equal to dy over x. Or we could completely eliminate n and determine that y over n is the same thing as saying delta y. So we could say that lambda is equal to d delta y over x. I hope you guys found this helpful, and if you have any questions, just leave them down below.